It's going to be a quick reminder video about linearization. So this was an example of the data set from the Spinning Thing lab. And if you look at what's on there right now, if I try to throw a line through it, it's not looking so much like a line. Basically, what you want to look for, right, if I can make this go just a smidge lower, if I try to throw a line through here and the data points at the beginning and the end are on one side of my best fit line and the data points here in the middle are on the other side of that okay fit line, then that's a tell that it's not a line, okay? So I'm going to add in here an expression for a curve because it looks kind of quadratic to me. So y equals ax squared. And then I can add in a slider. And somewhere in here, let's try 0.45. Oh, yeah. Okay. So that looks pretty good. So my equation then for this would be position equals 0.45 units times time. But if you look up here again in the equation, it's not x, it's x squared. So time squared. So what would the units have to be here? I'm squaring time, so that's going to be seconds squared. And I want the position to be in centimeters. So what do I take times seconds squared? Get left with centimeters. So I'm going to go centimeters. And then to cancel it out, to cancel out the second squared, I'm going to put a second squared on the bottom there. So there's my equation. Okay, and this was from a previous unit. One other thing that you'll get asked to do from time to time, though, is to present the linear form of a data set. And that means basically that we want to take this stuff here and plot it in such a way that we end up with a linear graph with a line. And so what you basically just do is look at what the expression is and compare it to y equals mx plus b, okay? Position is the y, m is the slope, and x would be time squared, okay? So I'm going to tell this thing to plot position on the y, and I'm going to tell it to plot time squared on the x. So if we go down here, that's already been put in here. This data set was x3 and y3. So here, this is a command line that's telling it to plot x3, which would be time, squared, and then y3, that would be the positions. So if you look down here at the data table, just to remind yourself, the times 2, 4, 6, 8, 10, we were marking the position every 2 seconds. Y, these are the positions. And again, based on my equation, position equals 0.45 centimeters per second squared times time squared. I want to compare that to the equation of a line, y equals mx plus b. Position is y, m is that thing, x is time squared. All right. This plots time squared on the x, position on the y, and shut this off. Now, if we zoom out, I can't really see it. Well, if you think about y, it's because y only goes up to 88. So I'm going to go into this thing and change the y-axis to go up to 100. That'd be 0. And now when we look at it, looks like a line. And now I'm going to turn this back on. Woo, goodness. B looks like it wants to be right about there. And here's that m. Again, in my quadratic equation, I had 0.45, and in this looks best if I have 0.45 as well. So the equation of this shouldn't say time anymore. Loving these announcements. This shouldn't say time anymore because I'm no longer plotting time on the x-axis. I'm plotting time squared. The units for it shouldn't be seconds. They should be seconds squared. Okay, so this would be done. What I'm going to have you do is open the link to another graph, and I need you to find the linear form of it. So you're going to need to submit back to me a graph with the linear version of the data. Okay, good luck.